This video will cover the material in section 11.1. Section 11, we're going to be dealing with quadratic equations. And in this video, we'll learn how to solve quadratic equations using the principle of square roots. And we will learn how to solve quadratic equations by learning how to complete the square. Okay, principle of square roots, we have talked about this. If x squared equals 25, then x is going to equal either 5 or negative 5. So if we have an equation where one side is something squared, we can just take the square roots of both sides as a quick way to find solutions. So again, if x squared equals k, then x equals the square root of k, or x equals the opposite of the square root of k, the negative square root of k. So we can use that to solve something like 5x squared equals 15. And this is asking for exact solutions and approximations to 3 decimal places. So just like we've talked about before, exact solutions are with the square roots, and approximations are go ahead and take the square root on your calculator. So the first thing we want to do is we want to get that x squared all by itself. We don't want that coefficient there. So we're going to divide by 5 and we're going to get x squared equals 3. Now that we've done that, we can apply the principle of square roots. And we find that x equals the square root of 3 or x equals the negative square root of 3. Those are our exact solutions. Now we take this one step further. Well, first of all, we can do that as plus or minus the square root of 3. And you'll use that a lot. It's just a lot quicker way to write it. But then to get the approximations, we'll take that one step further and take the square root of 3, which is rounded, as 1.732, and the opposite of that is negative 1.732. I will leave it to you to check that. Always check your answers. Check it with the exact answer, not the approximation. It might be off, and you might not know if it's off because your approximation is off, or it's off because your problem solving was off. So you always want to check with the exact answer. Here's another problem that we can solve this way. And again, we want to get that x squared all by itself. Okay? So we're going to subtract the 9 from both sides and then divide both sides by 16. So we'll get x squared equals negative 9/16. So x equals either the square root of negative 9/16 or x equals negative square root of negative 9/16. We can go ahead and do that. That means that x equals either 3/4 I or negative 3/4 I. We can take the square root of negative numbers. Remember, the square root of negative 1 is I. So again, you should check that answer. When you square I, remember that you will get negative 1. So in general, that doesn't have to be just a variable like x taken to the second power. It could be a variable expression, say x plus 2, quantity squared. And it's still going to work. We're still going to be able to take the square root of both sides. So it'll look like this. Here we have an equation to solve where we have an algebraic expression that is squared on one side and everything else on the other, in this case just the number. So what we'll do is we'll take the square root of both sides and we'll get x plus 3 equals 7. Or x plus 3 equals negative square root of 7. And now we solve for x by moving that 3 over in both of those equations. And we get negative 3 plus the square root of 7, or negative 3 minus the square root of 7. And we would write that as negative 3 plus or minus the square root of 7. This did not ask for approximation, so we won't give them any approximations. Okay, so not all quadratic equations can be solved that way, by the way. Because you can't always, you have x squared plus 3x plus 4. You can't factor that into anything squared. You can't get all the variable terms on one side and have them all be squared, so you're kind of stuck. So the second method that we're going to learn is called completing the square. We'll do lots more with this in class, and I'll show you a geometric interpretation of that will help. But I want you to get the basic concept now. Okay, so let's start by just doing this little exercise where we take the blanks in the equations and we're going to just replace them with numbers that make them true. So what number do I put after x squared plus 18x to make this a perfect square trinomial? Well, we're going to take half of the coefficient of x, so we're going to take half of 18 and get 9. And then we will square that number and get 81, and that's the number that goes there. And the 9 is going to go here because that's what got squared to do this. If you go ahead and factor this using any method, you will find out that you get x plus 9 squared. Now we can do this next one too. What number is going to go here? Well, we're going to take half of this and square it. Half of negative 7 is negative 7 halves. Square that and you get 49 fourths. So you put that in there and the 7 halves goes in here. The negative comes in because it's minus. That is the basic concept behind completing the square to solve a quadratic equation. So let's look at a couple examples. We have x squared plus 10x plus 4. This does not factor. If you put x squared all by itself on one side, you'd have an x on the other side. It wouldn't help to be taking square roots. So this one we want to complete the square on. So the first thing we're going to do is we've got to get rid of that 4. We want to get the 4 to the other side. So we subtract that 4. And see how they left space here? Because we need to put in the right number to make this a perfect square trinomial. And to do that, we'll take half of 10, which is 5, and square it and get 25. Now we're going to have to add that to both sides of the equation to keep it in balance. But now we have a perfect square trinomial on the left and nothing but numbers on the right. So we're definitely on the right track. We're going to factor that perfect square trinomial into the binomial squared, x plus 5 squared. And we're just going to combine the numbers negative 4 and 25 to get 21. Now we can apply the generalized principle of square roots because we have an algebraic expression that is squared on one side and a number on the other. So we'll do that. And when we take the square root of both sides, we get x plus 5 equals the square root of 21. Or x plus 5 equals negative square root of 21. We subtract the 5 from both sides, and what we get for our solutions is negative 5 plus or minus the square root of 21. Again, they did not ask for approximation, so just leave it like that. Best to give them both together like that with the plus or minus. You need to get used to that notation. You'll just be using it and seeing it a lot. So what did we do? We isolated the terms with the variables on one side. We made sure the squared term was first, and the first degree term was second. We have to make sure that that x squared has a coefficient of 1 for this to work. So we'll divide to make that happen. And then we just complete the square. In other words, take the left side of the equation and make it a perfect square trinomial. And then we'll factor it into a binomial squared and simplify the other side. And then we'll apply the principle of square roots, just like we did in the previous examples. So here's one that has a coefficient on the x squared term. Well, the first thing you want to do is get that 3 over to the other side. So we'll add the 3 to the other side. Now we need to divide by the 2 so we have a coefficient of 1 on our x squared term. So here we've done that. I don't know why they put parentheses around the other terms. It doesn't matter, but they're there. I think it's a little bit confusing because it's too easy to forget what you're going to add in there. But anyway, we divided both sides by 2. Now we need to figure out what number we need to add to both sides so that we have a perfect square trinomial on the left so that we can apply the principle of square roots. We'll take half of the coefficient of the x term, which is -2, square it, get 4, and add it to both sides. Then we'll factor the left side into x minus 2 squared. And we'll combine 3 halves and 4. And if you go through all the work with getting a common denominator, if you just put it on your calculator, you'll see that you get 11 halves. Now we have an algebraic expression squared equal to a number. And we can apply the generalized principle of square roots, which will get us x minus 2 equals plus or minus the square root of 11 halves. Add 2 to both sides to get x all by itself, and we get x equals 2 plus or minus the square root of 11 halves. Now, we can't leave it like that because it's not fully simplified until the denominator is rationalized. So that final step is to multiply top and bottom of the radical by the square root of 2. And when we do that, that's really bizarre because they added a square root of 2 in both. But anyway, when we do that, eventually, like this step right here, just forget about that. And what we end up with is 2 plus or minus the square root of 22 over 2.